As someone who enjoys nature trivia, I am disappointed to see the same 50 tidbits being circulated on the internet like the greatest hits of the animal kingdom. Cheetahs are swift, hyenas are dangerous, and everything in Australia wants to kill you. We know, so there are some weird things in nature that I believe you've never heard before. Insects have alien blood. Actually, it isn't blood, but something called hemolymph. It has been between 500 and 600 million years since humans and insects shared a common ancestor, so it is not surprising that there are some distinctions. When oxygenated, hemolymph turns blue or greenish because it is made of copper rather than iron, which is found in our veins. However, it is not employed to transport oxygen because an insect's oxygen requirements are met via respiration through the skin. This allows them to have a much more relaxed circulatory system. Their hearts beat far slower than ours, and they can even enter a condition of rest to preserve energy. The Weta, a New Zealand insect, has recently appeared on a number of lists because of a protein in its hemolymph that prevents the formation of ice crystals. This is not uncommon, as many beetles, flies, and bees share the same characteristic. Birds would die in space. I've seen a few blogs over the years argue that birds may thrive in a zero-gravity environment, with one even claiming that the only reason we've never taken them up is due to hygiene concerns. That couldn't be much further from the truth. The most fundamental reason birds cannot live in space is that most of them are unable to swallow, including the actual swallow. While birds are pro-regurgitators, they rely on gravity to consume their food and drink in the first place. That is why you see them dip their beaks in water and lift their heads to let it drip down. If we took birds to the ISS, they would most likely perish from thirst or drown while trying to drink. On a side note, pigeons have been placed on the Vomit Comet, a plane that flies in long parabolic arcs to imitate zero gravity for brief periods of time. They also struggled with flying. Moths possess an antibat arsenal. Bats are among the most fascinating and well-documented predators in the animal kingdom, so being a nocturnal flying bug appears to be a death sentence. It turns out that they are involved in a 50-million-year-old armaments race. The main issue with echolocation is that the target knows you're approaching as soon as you use it, exactly like in every submarine movie ever. Many moth species take advantage of this to the point that some can detect the distance to their assailant and react with greater haste as they get closer. My favorite approach is flight cessation, often known as dropping. Tiger moths use countermeasures to strengthen their defense. In a recent study, they released a series of clicks at the end of the attack to block the bat's sonar, leading them to miss up to 4 out of 5 times. Owls aren't very wise at all. It's difficult to gaze into the eyes of an owl and not believe that sucker knows something you don't. It does, in fact, but it just teaches you how to efficiently kill and eat rats. Although owls have huge eyes, their skulls are smaller. This leaves little room for a brain that, while capable of processing massive amounts of visual data, has the capacity to perform critical thinking. It is quite difficult to teach them even the most basic duties. When asked where the term wise old owl originated, Gary Jarrow, an owl trainer who worked on the Harry Potter films, answered, "I don't know who coined the phrase, but I certainly know it wasn't an owl trainer." Jumping spiders have great depth perception. Just because something has 8 eyes does not imply it has excellent vision. Field of vision is not synonymous with sharpness. Most spiders do not have a problem because they hunt by setting traps and waiting, but more nomadic hunters, such as the jumping spider, do. Only in recent years have experts begun to comprehend how the jumping spider's eyes function. The 2 major eyes are extremely complicated. Even though the lenses are fixed, it can achieve some level of binocular vision by moving the retina behind them. Those retinas are made up of different layers of light-sensitive cells. An image that is in focus on one layer is out of focus on the one just above it. Thus, the spider can precisely measure distance by comparing the sharp and hazy images. It does this so well that a Japanese company is aiming to apply the concept to a camera that could film in 3D with a single lens.